Carbonates are a type of mineral that precipitates out of water. And what's really great about that process is that means that when they precipitate out of the water, they trap everything that's in the water, right? So all the stuff that's living in there can be trapped up inside the mineral. And so in a lake environment, for example, this often happens along the shoreline of the lake. And you get even big things like microbial mats growing along the shore of the lake can be trapped up inside of minerals like carbonates. And so we see this happening in the geologic record on Earth. We see this going back hundreds of millions, even billions of years, this kind of process of trapping microbes in the rocks via precipitation of minerals like carbonates.
And in Jezero crater, there are locations, certainly seen from orbit, that look strongly as though they have carbonates.
Exactly. So using NASA instruments in orbit, we've actually identified carbonate minerals on the surface in Jezero crater. And in fact, there are a lot. It's one of the best places on Mars to see these kinds of minerals. And in particular, we think we see evidence for carbonates associated with the lake itself. And that's why we're really excited to go investigate them with the rover.
Yes, when you do your analysis of the crater, and we think it was filled with a lake, it appears that these carbonates are kind of like on the shoreline. What does that mean?
So that means that because they precipitated along the shore of the lake, or they could have, that they could have trapped anything that was living along the shore of the lake. It's a great place to go look for microbes that are living in that kind of very habitable near-shore environment where they have access to both the atmosphere and the water. It's the kind of place that a lot of different microbes can grow, and the carbonates themselves could actually trap those, and they could be waiting there for us to find.
When we look very ancient times on Earth, back almost 4 billion years, we see structures that we think are these stromatolites or records of these stromatolites. Just explain to me what they are.
Yeah, so these are rocks that are actually created by the interaction of these minerals precipitating and microbial mats growing in the lake. And so the act of the minerals precipitating can trap these microbial mats, and then the microbial mats keep growing on top of that. And so you build up these large macro scale structures over time that can form, large, several feet across mounds. They're actually creating rocks over time. And so we call these kinds of rocks microbialites, so rocks that are precipitated at least partially through the action of microbes at the surface. So that's the kind of thing we would absolutely love to find on Mars to look for biosignatures in.
But when we look at very ancient sources of life on Earth, some of it's quite controversial, isn't it? So do you think we're going to be able to, get a sample from a Martian stromatolite and bring it back and say, hey, this was life? Or is everybody going to be going, I don't know?
That's a great question. It's one of the challenges of this kind of investigation. But there are a couple things about Mars that are really appealing for this because, first off, Mars doesn't have plate tectonics. On Earth, that's one of the problems we have. We actually don't know what Earth was like 3 or 4 billion years ago because almost all the rocks from that time have been completely obliterated. All we have are a few mineral grains from that time period. But on Mars, those same sedimentary rocks formed in lakes, very Earth-like environments, are still just sitting there on the surface, waiting for us to go investigate them. And so in Jezero crater, we think that's a great example of this very early Earth-like environment that's still, the rocks are still there, just waiting for us to investigate.